The nation that pioneered the modern all-metal monoplane went to combat in obsolete gull-winged relics. Every standard war documentary misses how cataloging every aircraft ever built reveals this specific tragedy. Time, not pure aerodynamics, was the absolute enemy that finally conquered Warsaw in late September 1939. Entering service in 1932, the PWS-10 was designed to sever Polish reliance on foreign aircraft. Weighing 1,500 kilograms, it utilized a 400-horsepower engine to reach 200 kilometers per hour, with exactly 80 built. It operated as a frontline fighter for barely a year before swift relegation to training squadrons across the nation. It struggled to influence military engineering history, fading to obscurity. On paper, it was an interceptor. In practice, it was discarded. Introduced in 1933, this design replaced fabric biplanes to revolutionize European military aircraft history. The 1,300-kilogram machine featured a 500-horsepower radial engine, carrying 149 units into production, hitting 300 kilometers hourly. It became the first all-metal monoplane fighter equipping an entire national air force. Yet, technology advanced so rapidly that within 6 years, its revolutionary status was entirely erased. The machine solved the biplane problem. It created fatal stagnation. Deployed in 1935, this iconic gull-winged interceptor was designed as the ultimate defender of Polish airspace. Weighing 1,650 kilograms, its 600-horsepower engine enabled a 390 km/h top speed, with exactly 250 units manufactured. Pilots faced overwhelming numbers during the September invasion. They flew without armor or self-sealing fuel tanks against swarms of German bombers, utilizing desperate maneuverability to score kills. History remembered a glorious defensive stand. The doomed pilots remembered unprotected cockpits and jamming guns. Introduced in 1936, this advanced fighter was built to generate foreign revenue rather than defend its vulnerable homeland. It leveraged a 900-horsepower engine, pushing 1,900 kilograms to 430 kilometers per hour, yielding 190 airframes. While domestic squadrons flew obsolete designs, this variant was shipped abroad. It saw heavy combat with Greek aviators destroying Italian bombers. It was designed to enrich the national treasury. It is remembered for defending Greek mountain airspace. Scheduled for 1939, this enclosed monoplane was intended to drag the entire Air Force into the modern era. It featured a 2,400-kilogram weight and an 800-horsepower engine meant to reach 500 kilometers per hour. Yet only one single airframe ever flew. Bureaucratic delays and engine changes fatally stalled production lines during crucial pre-war years. When German armies finally invaded, the prototype sat grounded. One built, one lost. The math tells the rest. Rolling out in 1952, this licensed production model forced NATO to reevaluate Eastern Bloc industrial capacity. Weighing 4,800 kilograms, its jet engine generated 22 kilonewtons of thrust, pushing 227 units past 1,070 kilometers hourly. While essentially a cloned design, its rapid domestic manufacturing permanently transformed the destroyed nation into a formidable jet aircraft producer during the Cold War. They ordered a Soviet fighter. They got an aerospace manufacturing revolution. Arriving in 1954, this upgraded interceptor cemented the structural layout for subsequent national jet manufacturing. The swept-wing airframe weighed exactly 5,000 kilograms, housing a 26-kilonewton thrust engine to propel exactly 500 units to 1,075 kilometers per hour. It operated purely as a localized iteration of a foreign platform. However, the massive production run successfully established the precise tooling that maintained air parity. It won no wars. It built an industry. Entering service in 1956, this fighter forced a massive doctrinal shift in night interception strategies. It introduced afterburners to national military history, weighing 5,300 kilograms, with 477 built, reaching 1,145 kilometers hourly. Previously, air defense strictly relied upon station operators directing interceptors directly into blind visual range. This machine integrated radar, placing tracking capability directly inside the cockpit. The Air Force wanted ground control. The enemy had other plans. Deployed in 1961, this specific jet airframe was heavily modified to fill the vital gap in close air support. It weighed 5,600 kilograms, equipped with a drag chute and rockets, while exactly 90 airframes were produced. Originally born from an elite high-altitude interceptor lineage, the aircraft spent its career dragging through turbulent low-altitude air. It traded interception glory for unglamorous strikes. On paper, it was a fighter. In practice, it was flying artillery. Conceived in 1936, this twin-engine heavy fighter was designed to destroy bombers long before reaching domestic airspace. It weighed exactly 2,800 kilograms, wielding a 20mm cannon while targeting 460 kilometers hourly, though only 2 were ultimately built. The sleek airframe was brilliant, yet the domestic engines never produced adequate thrust. When forced to mount heavier foreign motors, aerodynamic performance collapsed. History remembered a beautiful design. The engineers remembered pure mathematical engine failure. Entering development in 1938, this light fighter was designed to provide cheap, rapid air defense utilizing lower-powered engines. It was engineered to weigh 1,400 kilograms, targeting 400 kilometers hourly top speed, utilizing an engine of 450 horsepower, though production never commenced beyond initial prototypes. The program ultimately collapsed when engineers realized military aircraft history was moving too fast. The design was obsolete before the first metal was cut. They ordered a simple defense. They got an engineering lesson. Designed in 1928, this aircraft was intended as a domestic high-altitude interceptor, bypassing expensive French imports. It weighed 1,700 kilograms, powered by a 450 horsepower engine, achieving 230 kilometers hourly, with exactly 1 prototype constructed. It failed rigorous testing completely, demonstrating aerodynamic instability and structure flaws that crews refused to trust during basic maneuvers. It was designed to replace foreign technology. It is remembered for proving domestic capability had its limits. Modified in 1932, this naval variant was designed to answer the difficult question of carrier aircraft doctrine for a navy with no carriers. This fighter variant targeted 1,600 kilograms and 300 kilometers hourly, yet only 2 maritime examples were ever built. While it proved the naval aviation concept was physically possible, the engineering and logistics required overmatched the strategic reality, canceling any hope for production. The machine proved a doctrine. It generated zero capability. Entering testing in 1929, this high-wing prototype was designed to prove that domestic all-metal construction could outclass contemporary fabric biplanes. Powered by a 500-horsepower engine, the 1,600-kilogram machine hit 300 kilometers hourly, though only exactly 2 experimental units were manufactured. The revolutionary metal structure and gull-wing visibility directly established the engineering foundation for the entire legendary line that followed it. One built, one lost. The math tells the rest. Introduced at the 1930 Paris Aero Show, this interceptor variant was designed to win crucial export orders through dramatic public performance. Targeting 1,800 kilograms and 330 kilometers per hour, it utilized a 500 horsepower radial, although only 1 prototype was ultimately completed. The stunning performance indeed captured headlines, making it military aviation history's darling, but no actual production contracts followed the spectacle. History remembered dramatic headlines. The engineers remembered zero cash flow. Developed in 1931, this fighter was a final, desperate attempt to squeeze more performance out of obsolete fabric biplane technology. The 1,600-kilogram airframe, powered by a 450 horsepower engine, achieved barely 230 kilometers hourly before exactly 2 prototypes proved unviable. Against the rising dominance of all-metal monoplanes within military engineering history, this machine offered no tactical value and immediate irrelevance. It was designed to maximize a biplane. It is remembered for finalizing the biplane era. Deployed in 1938, this specialized high-wing aircraft was designed as a dedicated Army cooperation fighter capable of short-field operations. It leveraged a 700-horsepower radial engine, enabling 240 kilometers per hour and weighing exactly 1,600 kilograms, with only 5 completed airframes total. In strategic planning, it was a precise tactical tool. However, the invasion's dynamic chaos demanded pure combat aircraft, leaving these advanced observers grounded or destroyed. On paper, it was tactical support. In practice, it was tactical friction. Conceived in 1938, this light fighter was designed to provide cheap, abundant interception for a defense budget overwhelmed by complex bombers. The 3,800-kilogram machine used a 700-horsepower radial engine meant to achieve 480 kilometers hourly, yet only one single prototype ever reached completion. Program delays fatally stalled manufacturing, and when German forces arrived, the entire factory was captured, terminating the light interceptor concept completely. They ordered an abundant interceptor. They got an industry captured. Modified in 1929, this was a domestic production variant designed to create immediate frontline capability through technology transfer. The 1,200-kilogram machine used an 1,800-kilometer range, hitting 280 kilometers hourly with 400 built. The entire fighter force relied on these airframes, establishing necessary industrial capacity and doctrinal consistency for years before more advanced domestic designs emerged. Industrial capacity was the weapon. The Sherman was the delivery system. The argument about the gun missed the point. Developed in 1970, this subsonic strike variant was designed to adapt established air parity doctrines to complex counterinsurgency warfare. Weighing 10,000 kilograms, it targets 800 kilometers per hour with 4 prototypes built, but never entered full squadron production after rigorous trials. Military engineering history proved these aircraft lacked the high speed and precise weapon systems required for survival against sophisticated air defenses in modern combat environments. It solved no military needs. It created political overhead. Developed in 1932, this prototype was designed to prove that complex, high-visibility, high-wing designs could outmaneuver traditional fighters. Targeting 1,800 kilograms and 300 kilometers per hour with a 450 horsepower engine, only one single experimental airframe was ever produced. Rigorous testing revealed severe handling limitations and pilot feedback. Concluding, this exotic aerodynamic approach offered negligible advantage over existing frontline designs. It proved the exotic concept. It generated zero combat value. Conceived in 1939, this sleek interceptor was the final domestic attempt to challenge contemporary military aviation history's benchmarks. Targeting a 2,500-kilogram weight, a 600-kilometer hourly speed, and a 900-horsepower engine, not one prototype was ever completed. Strategic inertia delayed the necessary specialized engine contracts, so when the invasion began, this critical project existed only as a scattered theoretical drawing. One built, zero lost. The math tells the rest. Modified in 1960, this indigenous jet was designed to repurpose a widely successful trainer platform into a capable close air support asset. It weighed 1,500 kilograms, hitting 720 kilometers per hour, with exactly 64 conversions ordered and executed. While the primary design excelled as a training aircraft, the attempt to create a frontline fighter variant ultimately produced a machine lacking necessary range, firepower, and protection. The jet that won the market is not in the history books. Developed in 1931, this prototype was designed specifically to answer the strategic threat posed by fast, high-altitude bombers. Targeting 1,800 kilograms, 350 kilometers hourly, and a 500-horsepower radial engine, only exactly one prototype variant was constructed. Engineers struggled with cooling limitations for the supercharger, which essentially capped the effective altitude and speed at levels no better than existing, cheaper models. The machine solved the altitude problem. It created different engine temperature constraints. Modified in 1957, this afterburning fighter variant was designed as a ground attack platform capable of high-speed penetration. The 7,200-kilogram machine generated 34 kilonewtons of thrust, hit 1,120 kilometers hourly, and exactly 2 prototypes were produced. Strategic planning believed high subsonic dash speed was sufficient for attack, but operational testing proved the heavy fuel requirements made tactical range impossible during simulated combat conditions. On paper, it was tactical attack. In practice, it was tactical mobility without fuel. Deployed in 1939, this final defensive variant was a desperate attempt to modify obsolete airframes with modern engines. It weighed 1,600 kilograms, achieving 440 kilometers hourly using an 800 horsepower engine, with exactly one prototype ultimately completed. Stratospheric engineering and logistics required overmatched the strategic reality, preventing full manufacturing of this advanced stopgap during the final chaotic days before the invasion. On paper, it was tactical defense. In practice, it was tactical inertia. Conceived in 1960, this indigenous supersonic interceptor was designed to challenge Soviet aircraft hegemony and define national aerodynamic capabilities. Engineered to weigh 4,200 kilograms, with exactly two prototypes targeting Mach 1.2, production never commenced beyond initial developmental stages. Bureaucratic pressure from the Moscow Pact deemed specialized domestic interceptors redundant, essentially forcing the cancellation of the program that defined military aircraft history. It was designed to define air superiority. It is remembered for defining political oversight. Deployed in 1963, this final modification to the swept-wing airframe was designed to fill the vital close air support gap. It weighed 6,000 kilograms, utilized an afterburner, enabling 1,200 kilometers hourly top speed, with hundreds produced or converted. While essentially an evolution of a defensive jet, it spent its career navigating highly turbulent low-level air on unglamorous strike missions. The jet that won the market is not in the history books. Introduced in 1990, this indigenous tactical jet was designed to replace Soviet imports and revitalize national aerospace capability with a versatile fighter. The 6,600-kilogram airframe utilized twin 900 horsepower engines meant to achieve 800 kilometers per hour, though only 17 ultimate units were manufactured. Bureaucratic delays and engine changes fatally stalled production lines, and despite years of litigation, the program ultimately collapsed after extensive flight testing proved insufficient combat performance. They ordered strategic capability. They got an engineering failure. Conceived in 1939, this highly streamlined interceptor was designed to challenge contemporary military aviation benchmarks for pure low-altitude speed, targeting exactly 1,900 kilograms and 1,900 kilometers range with a 1,400 horsepower engine. Not one prototype was ever completed. Strategic engineering errors essentially capped effective power during simulated performance tests. Concluding, this advanced aerodynamic approach offered no operational value to the defense strategy. History remembered a brilliant drawing. The engineers remembered zero thrust. Entering service in 1933, this initial production model forced regional adversaries to rethink their monoplane interceptor strategy entirely. Weighing 1,580 kilograms, a 500 horsepower engine allowed exactly 50 airframes to achieve 340 kilometers per hour. While revolutionary upon its introduction, rapid aeronautical advancements quickly rendered its fixed landing gear and open cockpit completely obsolete before formal hostilities even commenced. They ordered a regional air supremacy fighter. They got an outdated slow target. Conceived in 1939, this twin-engine interceptor was designed to resolve the underpowering issues of its predecessors. Engineered to weigh 3,300 kilograms, dual 700 horsepower engines were expected to push zero completed prototypes to 460 kilometers hourly. Material shortages and manufacturing delays ensured these incomplete airframes never received their engines before the September invasion halted all domestic aviation development permanently. On paper, it was a formidable interceptor. In practice, it was phantom capability. Developed in 1939, this machine was designed as a dedicated long-range escort to protect bomber formations over hostile territory. With a weight of 3,600 kilograms, two engines producing 1,200 horsepower were intended to carry zero production units to 500 kilometers per hour. Instead of flying offensive escorts, uncompleted assemblies were captured by advancing German forces directly on the factory floors. History remembered a bomber escort. The engineers remembered feared captured raw materials. Introduced in 1929, this parasol monoplane was designed to transition raw recruits into advanced fighter pilots safely. The 1,500-kilogram airframe utilized a 200-horsepower engine, allowing exactly 2 prototypes to reach 210 kilometers per hour. Pilots testing the machine reported severe control surface instability, declaring the aircraft far too dangerous for novice aviators learning basic dogfighting maneuvers. The aircraft was meant to save novice pilot lives. It actively endangered them instead. Initiated in 1939, this advanced design was engineered to prove radial engines could compete with streamlined inline motors. Targeting 2,400 kilograms and a top speed of 560 kilometers hourly, a planned 1,000-horsepower engine powered 0 completed airframes. The blueprints proved that heavy defensive armament and high speed were mathematically possible with air-cooled technology. Yet the impending invasion prevented any physical manufacturing. 0 built, 0 lost. The math tells the rest.